Okay, so the first thing I did, if you'll notice again, I am recording now, guys. I factored the top. I know that please stop talking. Please stop talking or you can leave. Okay? 4 and -1 multiply together to give me -4, but add together to give me +3. Okay? Now, removable discontinuity. There's none. There's nothing on the top and bottom that I can cancel out. Shh. Vertical asymptotes. That's where the bottom equals 0. So the opposite of -2 is 2. Okay, so x equals 2 is my vertical asymptote. Horizontal asymptote. I've got the degrees on the top. The degrees on the top are bigger than the degrees on the bottom. So if we look at the board, that means there's none. Okay? Now we have an oblique asymptote. So we're going to actually have to divide this. Okay? So I'm going to do that right here so I have enough room. I've got x squared plus 3x minus 4 divided by x minus 2. X times what gives me x squared? X. Okay, so I've got x. X times x, please stop talking. X times x is x squared. X times -2 is -2x, and then I'm going to change my signs and add straight down. Okay? All right. X goes into x minus 4 one time. So we get x. X minus 2 is -2. I'm going to change my signs. Add right down. I get -2 as my remainder, but this is my oblique asymptote right here. Y equals x plus 1. Okay. Oh, I didn't do this right. This was a 5. So this needs to be a 5. I'm sorry. So 5 times x is 5x. 5 times -2 is 10. And then we add straight down, and this should be -6, which doesn't matter, the remainder, because we're not going to use it. Yeah, it's x plus 5, yeah. -5x plus 20. Okay, x-intercept. How do we get a 0 on the top? We have -4 and 1 are my x-intercepts. They're my x-intercepts. Okay, we'll talk about in a second where it crosses the y and how to figure that out. Okay, and then my end behavior. As x approaches infinity, y should be approaching what? This is none, so it should be infinity, right? As x approaches negative infinity, y should be approaching negative infinity. Okay. Okay, now I'm going to put in my intercepts. Okay, first I'm going to put my vertical intercept at 2. Vertical intercept right at 2. It does not have a horizontal, but it does have a oblique asymptote, which means we have to graph this line as well. So we're going to go up to 5, and then we're going to go up 1 over 1, up 1 over 1, because that's my slope, or down 1, -1, down 1, -1. And we're just going to make sure it fills up my whole graph so that I can see where to put stuff. Okay, so I've got my oblique asymptote, I've got my vertical asymptote. I'm ready to put my graph on here. Again, you guys don't have to do this if you can see it really well, but I think it's hard to see my x and y axes. So I'm outlining them in black. Okay, so I know that it crosses right here and right here. Okay, so I really need to know where it crosses the y-axis. Okay, the great thing about this is if you just plug in 0 for y, you're going to find that your y-intercept for this is 2. Okay, so I know that my graph goes like this. Okay, but I need another spot. If it goes in between these two lines here, it has to go in between these two lines here. So that's what my graph looks like for number 2. Okay, Do you guys want me to do number 3, or do you want to try number 3 on your own? Okay, why don't you guys try number 3 on your own? I'm going to leave 2 up here. Try number 3 on your own. The first thing, fill out this whole chart. If you can't get to the graphing part, we'll do that together. But fill out this whole chart, and we'll check your answers. Okay, I'm just going to give you a few minutes to do this, so we're not using too much time. First thing you need to do is factor the top and bottom. No, you don't.
Makes us think hard. We don't factor.
You can factor the top and the bottom. Put your phone back down. Go do this problem right now, and then you can come back. We're almost done. Go sit down. Jordan, go put that back and go sit down. Go put it back and go sit down, please.
No, put it right there. Put it right
Okay, guys, I'm going to give you one more minute, since obviously some of you do not feel like doing this right now and are instead playing around. Just going to give you one more minute. I want to remind you that you do have a quiz on Friday over this information. Whole is the same thing as removable discontinuity. It's the same thing. All right, guys. So for number 3, first we factor it. We get x times x plus 3 and x plus 5 times x plus 3 on the bottom. Your whole or your removable discontinuity is x equals negative 3. Shh. You need to be quiet.
Why is it x equals negative 3?
Because those are the ones we can cancel out, yeah. Vertical asymptote is x equals negative 5. That's what's on the bottom. The horizontal asymptote is y equals 1 because the numerator's degrees and the denominator's degrees are the same. So it's the leading coefficient.
What is it?
1. Y equals 1. Horizontal, you have to say y. There is no oblique asymptote. You can't divide one into the other. Okay? The x-intercept is 0, and so is the y. As x approaches infinity, y approaches 1. As x approaches negative infinity, y approaches 1. I graphed my horizontal and my vertical asymptote. I graphed where my x and y intercept would be, and then I drew graphs on opposite sides of it, because they always have to be opposite each other. Okay, so we can have a choice. Would you like me to do one more with you, or are you guys good? Okay, so let's do one more, and we'll just worry mostly about the graphing part. So I think really we can do this one really quick together. Just fill it out and then get to the graph part. Okay? No. X minus 1 and x plus 1. And x plus 4, that's really done quickly. There's no holes. Your vertical asymptote, I'm sorry, we're going to wait until everybody shuts up because I'm not sure why you're talking right now. Your vertical asymptote is x equals negative 4. Your horizontal asymptote, your numerator, is bigger than your denominator. So there is none. Okay? Your oblique asymptote, if we go x squared minus 1 divided by x plus 4, x times what gives me x squared? X. X times x is x squared. X times 4 is 4x. We're going to subtract right down. We get negative 4x minus 1. Okay? X times what gives me negative 4x? It's negative 4. Negative 4. Negative 4 times negative 4 is a negative 16. But we change them and add straight down. We get 15. So our oblique asymptote is y equals x minus 4. Our x-intercept, it's when the top gives us 0, is x equals 1. Okay? Is x equals 1 and x equals negative 1. Okay? End behavior, as x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches negative infinity.
Yes.
Okay, so we're going to start with doing what? What am I going to start with when I graph?
We'll start with the.
So first I'm going to copy this. Okay, and then I'm actually going to start with my asymptotes. Okay, so what asymptote do you want to start with first? Vertical asymptote, I think, is easier to do first, yep. So we're going to do a vertical asymptote at negative 4. That's my vertical asymptote. Okay? Okay, what do I do next? Do I have a horizontal one?
No.
So I do not have a horizontal asymptote, so that can't be on there. But I do have an oblique asymptote. So I'm going to put a dot at negative 4, and then go up 1 over 1. Please make sure you do this across your whole graph so you can get full credit on your next quiz. Across the whole graph, guys.
When we get our quiz, can we like make sure we can see the graph?
Yeah, it's better. I already made it up. It's easier to see. Okay, and it says that our x-intercepts are at 1 and negative 1. Okay?
Wow.
All right.
No, I see. No, I see.
We cross the y-intercept right here, so it goes like this. And that's it. That's all you can see. There's something over here, but you can't really see it. Okay? All right, I am going to stop the recording now. Your homework is the other sheet that's up here.
Yep.
Okay?
We already know that.
Yes, you did.